Hey guys, welcome back to Genius Tutorials 2015. So today we'll be doing kinematics constant motion problem bank. So to get right into it, first question is talking about the diagram to the right. Shows an object moving in a straight line. And as asking at what point is the farthest from the starting point. So here we have a position versus time graph. And so a position versus time graph shows the displacement of the object from a certain reference point. Of course, the displacement is going to be 0 at the reference point. So whenever we are along this horizontal line of y equals 0, we are at the reference point. So therefore our farthest point from that reference or starting point will be point B, because as you can see, it's vertical, its displacement from the reference point is the greatest. On this graph, it would be the amplitude of these waves. So all these vertical distances, point C is of course at the reference point, and point B would be farthest from the reference point. So point B, number 1, is going to be at point B. Moving on to question 2, has 2 parts to it. The question reads, a car travels in a straight line with an average velocity of 80 kilometers an hour for 2.5 hours, and then with an average velocity of 40 kilometers an hour for 1.5 hours. So part A is asking us to calculate the largest displacement for the 4-hour trip. So we can use our equation. Displacement is equal to average velocity times time, or change in time. You can also say change in time. So in order to find our largest displacement for the entire 4-hour trip, we're going to have to, since the average velocities are different along the 2 times, we're going to have to find their displacement separately and then add them together. So we'll say the first part is going to be displacement 1 is equal to its average velocity of 80 kilometers an hour times 2.5 hours. And then we have our second displacement for the second part of the trip is going to be 40 kilometers an hour for 1.5 hours. And if you get those 2 answers and add them up, the sum of those 2 together will be 260 kilometers. So that's the answer to part A. Part B is asking for the largest average velocity of the total trip in kilometers per hour. So from our equations that we used before, we have average displacement equals average velocity times time. So therefore we can get average velocity by doing displacement divided by time. And our total displacement was 260 kilometers, and we were traveling for 2.5 plus 1.5 hours. So that's a total of 4 hours, and 260 divided by 4 hours is going to get you 65 kilometers an hour for the average velocity of the entire trip. Now question 3 is asking about it shows the position of a particle versus time, and it is asking to calculate the average velocities for the time intervals A, B, C, and D indicated in the figure. So as you can see, so the average velocities from our old equation we said is is displacement over time. So from this graph showing position, we can calculate the displacement, and we have the time intervals. So we'll say for time interval A, well, you can see that displacement, well, to start off, displacement is equal to final position minus initial position. So that's always going to be what displacement is. So in the case of or time A, interval A, its final position and its initial position are the same. So when you subtract them, you will get 0. And then displacement over time is going to get you average velocity. So if their displacement is 0, their average velocity will be 0. So for time interval A, it will be 0. 0 kilometers or 0 meters per second. For time interval B, our initial position is 4, or our final position is 4. Our initial position is 3. So 4 minus 3. And our time interval is from 7 seconds to 4 seconds. So 7 minus 4, so that gets us 1/3 meters per second. This is for time interval B. For time interval C, our position is -2. For final position, our initial position is 4. So -2 minus 4 gets you -6 over again, 3-second interval from 7 to 3. So -6 divided by 3 seconds is going to get you -2 meters per second. Now, velocity is a vector, so it also has a direction, not only the sign, or not only the scalar part, but also the vector part. So this just means it is moving in the opposite direction, so opposite direction from your reference point. Finally, for interval D, our final position is 1, and our initial position was -2. So 1 minus -2 is going to get you -3 over a 3-second interval, or +3 over a 3-second interval, which gets you 1 meter per second. This is for interval D, and this was for interval C. So there's question 3. Alright, on to question 4. Is asking, a baseball pitcher throws a fastball with a speed of 150 kilometers an hour. Calculate the time it takes to reach the catcher, which is 13.7 meters away. So this one, again, is a simple one. It's just using displacement. I'm going to start using displacement equals average velocity times time. So it is asking the time, so we want time is equal to distance over, or displacement over velocity, and its displacement, it is 13.7 meters away over a velocity of 150 kilometers an hour. But you cannot just put 150, that is in kilometers, and the distance is in meters, so we're going to have to convert one. Let's convert the 150 kilometers an hour to 150,000 meters, and that will give us a time of dividing both of those will give us a time of 9.133 times 10 to the minus 5 hours, and of course you could convert that into seconds if you wanted to. Just multiply by 3600, and you would end up with 0.3288 seconds. So this is number 4. Number 5. Number 5 is saying the Olympic record for the marathon is 2 hours, 9 minutes, and 21 seconds. The average speed of the runner is 5.436 meters per second. Calculate the distance. Again, it's another displacement equals velocity times time. This time you're calculating the distance, so distance is equal to VT. Its velocity is 5.436 meters per second times a time of 2 hours, 9 minutes, and 21 seconds. You can convert that into seconds. So into seconds, that would just be 2 times 3600 plus 9 times 60 plus 21 seconds. Gives you 7761 seconds. And the answer to that is going to get you 42,189 meters approximately. This is approximately meters. So, yeah. Question 6. Now, question 6 is a little tricky, so I'm going to draw a diagram. So, basically, what the question is saying is that you have there's a flagpole, which is your reference point. So, it's your reference point, and you have a runner A, who is a distance of 6 meters. Is that right? Yes, 6 kilometers west of the flagpole, and you have another runner who is 5 kilometers, runner B, from east of the flagpole. And each one is running towards the flagpole, but runner A is running at 9 kilometers an hour constantly, and runner B is running at 8 kilometers an hour constantly. So it's asking that once these two runners have intersected paths, or basically are in the same position, what is their displacement from the flagpole? So initially we can see that they are going to meet on the west side of the flagpole, somewhere in this region, somewhere like near this position. And the reason for that is they both start at the same time, but the time it takes for runner A to get to the flagpole is longer than the time it takes for runner B to get to the flagpole. And that's just by using your time is equal to displacement over velocity. So 6 kilometers over 9 is larger than 5 over 8. So therefore it's gonna take longer for runner A to get here. So in that the time it takes runner B to get to the flagpole, runner A is still running this direction, and they'll meet up somewhere on the west side. So we know it's going to end up on the west side. Now, to find the position, so once they meet up, assuming in this somewhere in this region, they are going to be a certain position from X, or from the reference flag point, which is, we'll say, a distance X. So times are going to be equal, so time for A will be equal to the time for runner B in this case. So the distance he ran over his velocity is going to be equal to runner B's distance ran over his velocity. So his displacement, at that point, he's going to have run a total of 6 kilometers minus the distance from the flagpole. So it's going to be 6 minus X over his velocity, which is 9. And we set that equal to runner B. In this case, runner B is going to run 5 kilometers plus the distance X. So 5 kilometers plus the distance X over his velocity of 8. So now you can just cross multiply, which gives you ultimately 48 minus 8x. 48 minus 8x equal to 45 plus 9x, which gives you 3 equals 17x, and x, the displacement from the flagpole, is going to be approximately 0.176 kilometers. We determined that would be west of the flagpole. So that's question. That is question 6. All right. Next question, question 7. We won't be doing here because it requires the spreadsheet on gravitykills.com. So just reference the spreadsheet. It's going to be on gravitykills.net. .net. Yep. So question 8 is showing us a figure to the right depicts the motion of a walker moving in a straight line with a changing velocity. Qualitatively describe the walker's location relative to the reference point, direction of the motion, and rate of motion. So his location on this graph, his location relative to the reference point, so let me just zoom in here. Here we go. So his location relative to the reference point, remember the reference point is at a position of 0. So he is a little bit to the negative direction of it, and during his motion he gets closer, and then once he passes it, he continues to move past it and then moves away from it again into the positive direction. His direction of motion, again, he's moving in the positive direction, and you can see that by seeing his final position and his initial position. Subtracting the difference, 6 minus -2, will get you a displacement of positive 8. So he's moving in the positive direction, and his rate of motion is increasing because rate of motion is referring to the velocity. So rate of motion is velocity. And velocity on a position versus time graph is the slope of the curve. So the slopes are changing. The slope here is not the same as the slope here. Slope here is much steeper at the top of the graph. So since the slopes are getting steeper and steeper along each point, so each point, the slopes, which is the line tangent to that graph, they're getting steeper and steeper. And the slope of those lines on each point represents its velocity at each of these points. Therefore, its velocity is increasing along this curve, or we can say that is a positive acceleration. On question 9, zoom out. So question 9 is asking about this graph, and it's asking a description, so we'll just talk about it basically. So again, a position versus time graph. Along this first segment, it has a constant velocity because the slope is constant along that whole line, but it is positive velocity because it is positive slope. Along this horizontal flat part, it is also a constant velocity, but that velocity happens to be 0 because the slope is 0. Along this point, it is a constant velocity because it is a straight line with a constant slope along the whole line, but it is a negative velocity because it's a negative slope. And on this part, it is moving toward the reference point, and then once it passes, moves away. So that's number 9. And last but not least, question 10 is asking to describe the object's motion yet again. So along from interval 0 to 1, again, it is a straight line with a constant velocity. From 1 to 2, it is curving. However, it is curving so in a manner that the slopes are getting less and less steep. So you can, if you put tangent lines along that line, along that curve, the slopes will get less and less steep. So its velocity is decreasing. It's still moving away from the reference point because you can see the displacement still getting bigger farther away, but the velocities are slowing down. Along here, it's at rest with a constant velocity of 0. Along 3 to 4, it is now speeding up because it's at rest, and then the slopes get steeper and steeper and steeper, so it is curving upward. And then from 4 to 5, it is again a positive constant velocity. So that's a kinematics constant motion problem bank. Hope that helped, and until next time, see ya.